Hello everyone, I welcome you all to today's session of the concept videos. So in today's class we shall be taking up the continuing topic from geometry. So if you remember, the series of videos were stopped at the last video was at geometry, wherein we covered quadrilaterals, we covered circles, we covered triangles, right, and other such similar aspects. In today's class we shall be starting with three-dimensional geometry. So I will be taking up minor concepts, right. Today it will not be a lot about problem solving. Today we will be discussing various concepts that we have in the mensuration chapter, particularly pertaining to the three-dimensional geometry. Then we shall take up the examples in the subsequent classes. Alright, I intend to take around 2-3 examples, alright, from this chapter, which I will do in the next video. Alright, today's video is all about just sharing the concept, the approach, alright, the formulae pertaining to different kind of solids that we will be seeing in this chapter. Now, if you are new to this channel, alright, if you are watching this video for the very first time, let me just tell you that we have been carrying out this series of videos keeping the CAT examination that is coming very fast our way, alright, in mind. So in this series of videos we do two things, right. One is we call it as a concept video. For example, the video that we have for today, wherein I would be explaining various concepts that we have in different topics, right. That is one concept video wherein there will be a concept attached to a question. Second is questions video, right. So CAT level questions will be taken up, alright. When I say CAT level, CAT asks questions from all categories: easy, medium, tough, very easy. So I take up questions of all types, discuss those questions in separate set of videos, right. So in case you are new, please subscribe to the channel, right, and please watch all our previous videos, right, so as to gain some exposure to new questions, right. So let us get started with the session for today. So today we have the topic which is mensurations. So when we say mensuration, mensuration is basically the branch of mathematics or branch of geometry that deals with measurements, right. Now when I say measurements, measurements pertaining to angles, areas, length of the line segments will all come under this again, right, but I am not going to take all of that, right. What I will be majorly focusing on is solids, 3D geometry. So when you look at the solids in mensuration, we have majorly, broadly, 4 types of solids that we come across. One of the categories we call them as the prism. That is one type of solids. The second type of solid we call them as the pyramids. The third category are the spherical solids, spheres, hemisphere. And the fourth, the final one, are a special type of solids which are called as frustum. So frustum is basically a pyramid where it is cut open, alright, that is the frustum, that is a separate category. So if you look at the prism, let us try to understand each of the words firstly, and then we will go for the formulae, the various things that we need to remember, etc. in each of them. So if we start with prism, so prism is basically a solid which has an identical top and base. So any solid which has identical top and base, for example, if you say the base is a triangle, the top should also be an identical triangle, and then the corresponding vertices will be connected like this. Now the figure that will be originating out of this, alright, forming out of this, we'll call it as a prism. There is a top, there is a bottom and top. Or if you say, if I take the base as a pentagon, the top will also be an identical pentagon. Again you connect the corresponding vertices, you get a figure like this, rough diagram like this. This is also a prism, right, with a pentagon base, right. It could be a square also, the base could be a square, the top could also be a square. So that way any solid which has identical top and base, we call that as a prism. Now some commonly known prisms that we have that comes up in our competitive exams are, there is something called as cube, there is something called as cuboid, and there is something called as cylinder. There could be others also, but these are the most common types, alright. So basically when we will be discussing the formula and all, we will be discussing from these point of view, right, from these 3 figures point of view. So this is what is prism. So on account of the definition of prism, so what you will notice is there is something called as lateral surfaces in a prism. Now what do I mean by lateral surfaces? Lateral is surrounding, right, around us, right, surrounding. So if you look at the lateral faces or surfaces of a prism, you will find them to be rectangles. Let me just show you one more time. If I take the base to be a square, top will also be an identical square. So when you connect the corresponding vertices, it would look like this, roughly like this. Now look at the surrounding walls. For example, best thing would be, just imagine the room that you are sitting in. It will be a prism, because the room generally have a rectangular base and a rectangular top, right. That would be a prism. So if you look at your 4 walls around you, there will be 4 walls around you, right, only 4 walls, all right. In a room, if you take, there will be 4 walls around you. The shape of each of the wall will be a rectangle. So here, in case of prism, lateral surfaces will all be rectangles. So this is a point to be noted, this is a point to be understood. So these are some basics about prism. Now when you move to pyramid, how do pyramids differ with respect to prism? Let us try to understand. So look at pyramid. So pyramids are solids which have only a base. There is no top. So top will only be a point basically, right? It will just be a point. Thus a regular pyramid will look like this. So if you take a square base, there will be a base, no top. So top will be a point. Now this point will be connected to all the vertices of the base. We will get a figure like this. So this is how a pyramid will look like. Of course you need to have slightly imagination power to imagine how would a pyramid look like. Best example would be Egypt pyramids. You can just recall that, right. So you can visualize how a pyramid would look like. Egypt pyramids I think will have a square base again, if I am not wrong, right. Square base, there is a top, it would be like this. Of course the figure is not coming out properly because I only have a 2D space here on the board, right, but you need to visualize it. So any solid which has a base but no top, we call it as pyramid. Now under pyramids we use a particular term which is called as right circular pyramid. So there is one thing called as pyramid, there is something called as right circular pyramid. All are examples in our competitive exams, in your classes. You would be dealing with only right circular pyramids. Now what do we mean by right circular pyramid? The simplest definition is like this. So for example, if you imagine a pyramid here on my hand, right, imagine this. So there is a top. Now from this top, imagine this to be a square pyramid. So the base is square. So from this top, if I drop a perpendicular, that perpendicular coincides with the center of the base. It will always coincide with the center of the base. Such pyramids are called as right circular. Because see, imagine a pyramid could also be like this. So when I drop a perpendicular here, it will not necessarily coincide with the center of the base. Center of the base will be somewhere here. It is not coinciding with that. So we do not want such pyramids. We will not be considering such pyramids. We will always be considering right circular pyramids. Now some commonly known examples for pyramids are square pyramids, where the base is square, and more importantly, most commonly available is something called as a cone. So cone is an example of pyramid, right. So cone will appear like this. There will be a circular base, there will be a single point. It is a right circular cone again, it will not be stated every time, right. So that would mean if I drop a perpendicular from here, it coincides with the center of the base, the center of the circle, alright. Now this dimension, this vertical dimension, we call it as the height of the cone, the perpendicular height, h we represent it. This is called as the radius of the cone, radius of the base of the cone, r, we represent it as r. Now please notice there is this one more segment that we have here, this one. There is also a height of a special type, we call this as slant height, we represent this as L. So that means if you look at this triangle which is formed here, I am highlighting the triangle. If you look at this triangle here, it will be a right angle triangle. So what happens in a right angle triangle? Naturally in right angle triangle, you have the perpendicular height as h, radius as r, this is the slant height L. Those are the dimensions. Let me clean this. So here if you apply the Pythagoras theorem, we will get L square is equal to R square plus H square. So, that is the relation that you have between the 3 dimensions out here in a cone particularly. Now, similar relationship can be derived for other pyramids also. See, the reason why I am writing this particular case is because cone is most commonly asked in our competitive exams. Now, one more point under pyramids is, if you look at the lateral surfaces here in case of pyramids, they will all be triangles. They will not be rectangles anymore, they are going to be triangles. You can again visualize it, or you can just draw a pyramid and check for yourself. So, if you try to visualize this pyramid here, so lateral surface is this is the face which is facing you, it is a triangle as you see. Alright, so these are some basics that we have about pyramids. We will get into more details, and as I have been saying, this session is mostly about formulae and concepts. I will not be taking up any major problems at this stage in this video, we will take it up in a subsequent video in case you are wondering about the questions. Now, sphere, if you look at the sphere now, so sphere is that circle in 3D. If you take a circle, you extend it beyond 2D, you take it into 3D, you will get a sphere. So, sphere has only one dimension, which is the radius. So, sphere will have something called as R, that is it. Okay. Now, in this sphere, if you cut it into half, then it would appear like this, right? A semicircle in 3D. This is called as hemisphere, right? Sphere, hemisphere. So, they would be having their own measurements, volume measurements, surface area measurements, alright, etc. But the point to be noted here is, if you take a sphere, like this, there are no lateral surfaces. So, basically everything is curved, everything is just curved, whereas if you take a hemisphere, please understand, there is one lateral surface at the bottom, it is flat. It is flat at the bottom, rest all is curved. So, in this case there is no flat surfaces, in this case there is one flat surface because we are cutting it. We will talk more about this when we will get into the formula stage. Now, let us move on to frustum. Let me basically explain what a frustum is. I will share the formula later, 5 minutes later. So, how is a frustum formed is, if you take a pyramid, it looks like this. You cut it with a plane parallel to the base. So, if you cut it like this with a plane parallel to the base, imagine this is the plane with which we are cutting it. Remove the top portion. So, if you remove the top portion, what will you be left with? You will be left with this kind of figure. So, if you look at this figure, this is not a pyramid, because there is a top also. This is not a prism, because top and bottom are not, the top and base are not identical. It is not a prism also. Such figures are called as frustum. So, as you can see, a frustum will have both a top and a base. Top and base both will be there, and they will not be identical. So, for example, if the top has a radius of small r, base will have a radius of capital R. Something bigger, something smaller, but they will be different. Alright. So, this is what is frustum basically. How do we calculate the formulae for volume and all? We will look at that now. Let me just clean all of this, whatever we have written so far. Let us clean this and then move on to the next discussion stage, wherein I will be sharing some general formulae and then some particular formulae also. Okay. Let us move on to prism first. So, under prism, so the very first figure that we shall be discussing is cuboid, but even before that there are some general formulae that we have. See, there is something called as lateral surface area of a prism. So, what do we mean by lateral surface area is areas of the surrounding walls, the 4 walls that we have. So, area of the lateral surfaces will be given by the general formula perimeter of the base into the height. So, when you do this, you will get the LSA of any kind of prism. TSA, total surface area. So, total surface area is lateral surface plus the top and the base. So, it will be LSA plus area of the base plus area of the top, which are identical basically. So, you can simply write 2 into area of the base also, because in prism base and top are identical. If area of the base is 10, area of the top is also going to be 10. Volume. Volume is given as area of the base into the height. See, please understand, in case of prism there is only one kind of height, perpendicular height. In case of pyramid you have this problem, you have a slant height also, you have a perpendicular height also. Here there is only one type of height. So, after this general formulae, and I would suggest you all to memorize this, understand this, because if you understand these three, there is no other formula in prisms to be remembered, right? Everything can be easily derived. So, if you take a cuboid, so in a cuboid you have length, breadth and height dimension. So, cuboid is like rectangle in our 2D, alright, rectangle has length and breadth, cuboid has length, breadth and height. So, if you take cuboid, so one of the things that we have is LSA, lateral surface area is perimeter of the base. Perimeter of the base formula for rectangle is 2 into L plus B into height h. 2h into L plus B is the formula. Total surface area of a cuboid, LSA plus area of the base, which is L into B, area of the top, which is also L into B. So, when you add that, you will get 2 into LB plus BH plus LH. Volume. Volume will be given as, right, area of the base, L into B into height, LBH. So, these are the three commonly asked dimensions that we have in case of this prism, right, in case of this cuboid, right. Now, besides these three, there are few other things that we have in a cuboid, which I will write it here, right. Please note this down. So, besides these three, in case of cuboid, cuboid looks like this, by the way. It is like a rectangle in 3D. A cuboid is like a rectangular box. Okay. So, in this, if you look at, there are two types of diagonals that we get to see. One of the diagonals is like this. So, if you take on this face, this right face, there is this one type of diagonal like this when you connect these two vertices, right. There is one more type of diagonal, it is called as body diagonal. So, what happens in body diagonal is, the diagonal passes through the body, alright, of the solid. So, for example, imagine you connect this vertex with this vertex, imagine this. If you connect this with this, it will be a face diagonal, it will be on this front face, but if you connect like this, it will be moving like this through the body. So, there are two types of diagonals that we have, and their values are given as, if you take face diagonal, so face diagonal on this particular face, for example, if I assume this to be the length, this to be the breadth, this to be the height. So, there can be three different formulae, three different expressions for face diagonal. They can be like root over L square plus B square, or B square plus H square, or L square plus H square. But if you take body diagonal, it is going to be root over L square plus B square plus H square. Okay. So, these are two additional formulae that I would suggest you to remember, right, to note down in case of a cuboid. Now, when you move to cube, next type of prism, a cube. Cube is like a square in 2D, square in 2D becomes cube in 3D. So, it looks like this, all its dimensions will be equal. So, height is also A, length is also A, breadth is also A, everything is A, same dimension, just like square. So, for this LSA, lateral surface area, the formula will be 4A square, perimeter of the base 4A into height A. Total surface area will be 6A square, volume will be A square into A, area of the base A square into height A cube. Face diagonal, it will be root 2 into A, there are no three different formulae like cuboid, single formula because L equal to B equal to H happens in this case. Body diagonal, it's going to be root 3a. It's going to be root 3a. In the previous formula, you just put L equal to B equal to H equal to a. You will get these two formulae also. So this is what is cuboid. Now when next, one more prism that we have is cylinder. So cylinder looks like this. There is a top circle, bottom circle identical. Right? A cylinder will look like this. So it will have only two dimensions. One is the radius, other is the height. Height means perpendicular height only, h. Only two variables r and h will give you all the values. For example, this had only a. Cuboid has lbh. This is only two, r and h. So lateral surface area, or it's called as in this case curved surface area, because there is no lateral, there is no flat surfaces, it's all curved, right, circle, will be given as the formula is perimeter of the base into height h. Total surface area 2 pi r into r plus h. Volume pi r square h. Area of the base into height. Now there is no body diagonal or a face diagonal of course present in case of a cylinder. So those are some commonly appearing figures, solids, and their respective values for volumes, for areas, for body diagonals wherever possible. Now next let us move on to pyramid. So in pyramid, as we said, we will take the case of the most commonly known pyramid, which is cone. There will be r, there will be h, two dimensions again, right. Of course, the third dimension is born, which is slant height. Right. So first thing, curved surface area in case of pyramid. So I again, before I share this, the formula for cone, let me share the general formula. Lateral surface area in case of pyramid is given as half perimeter of the base into slant height, not the perpendicular height but slant height. Total surface area is LSA plus area of the base. Volume is 1/3 area of the base into height h, So these are the general formulae that you have for pyramids. So if I write the same values for cone, for example, the curved surface area will be given as half perimeter of the base, half into 2 pi r into slant height L. Total surface area will be CSA plus area of the base. When you apply that, pi r into r plus L. Third is volume, which will be 1/3 area of the base into height, perpendicular height. Please note, for LSA we are using slant height, for volume we are using perpendicular height. Okay. Point number 4, the relation between the three, we have written this already, but still let me just write it down once more. Point number 5, imagine if I cut the cone at this green level such that this height here of this smaller cone happens to be h1 and this radius here of this smaller cone happens to be r1. Then in such a case we will have the following relation: h by r, the ratio of the height and radius for the larger cone, will be equal to h1 by r1. And this can be proved very easily by using similarity of triangles. We can easily use that and get to the result, this result. So this is with respect to pyramids. So when you come to sphere, very simple straightforward formula that we have. One is the formula for total surface area. So total or curved surface area in this case will be 4 pi r square. This is your curved surface area. And there is one more formula, which is volume, which will be given as 4 by 3 pi r cube. Now when you come to hemisphere, there will be two types of areas. One is the curved surface area, only the curved area, it is half of this. There is something else called as total surface area now, because now you have a flat surface at the bottom. So that flat surface will also be a circle of area pi r square. So it will be 2 pi r square plus pi r square, 3 pi r square. Volume will be half of this, pi r cube, right. So these are some general formulae that we have and specific formulae that we have for special figures, right. General formulae that we have discussed, perimeter of the base into height, area of the base into height. For pyramid we discussed different set of general formulae. Please do remember those general formulae. You need not even remember these results, you will be able to derive it in the exam, right. Whereas those formulae I would suggest you please memorize them, right, because questions from your mensuration chapter which involves 3D figures will typically be like this. They will ask you to find the volume of a particular solid. If you do not know the formula, you cannot really find the volume. Now one last thing that I would like to quickly take up is frustum. So frustum, we have lateral surface area, we have total surface area, general formula, and we have volume. How do we find this? So I will just draw a frustum here first. It will have a top and a bottom base, but different, they will not be same, identical. Imagine for the top, area is 80, perimeter is PT. For the bottom, area is AB, perimeter is PB. Say height of the prism is H, slant height is L. These are some common dimensions that I will be using for writing down this formula. Lateral surface area will be given as half, just like your cone formula, half into perimeter of the base. Here also half perimeter of the base plus perimeter of the top into slant height. Here also you will get slant height. Total surface area is LSA plus area of the base plus area of the top, which will be different. Volume 1/3, area of the base plus area of the top plus square root of area of the base into area of the top into height H, height of the frustum. So this will give you the volume, this will give you the lateral surface area. Now do not try to derive it. Of course, it is not that difficult to derive this formula to get the result without using the formula also, it is very much possible. But these formulae will make our journey of solving a question very, very easy. But there is one effort that you will have to put in right at the beginning, memorize them. Okay, please memorize them, it will help you at a later stage. So these are the formulae, general formulae that you have for frustum. Now if that frustum is of cone, you can use this as R. So pi r square will be area of the base, 2 pi r will be perimeter of the base. So accordingly the formula will change. Alright. So for today's session, right, this is what I had in mind, right. So as I said, no major discussion on formula front, the question front, right. Only the formulae have been covered in this class, right. I hope you have followed them. Please do revise them regularly until you learn them really well, right. We will take up more videos, right, wherein we will be covering some questions also, right, but we will do it in subsequent videos. Right. On that note, let me end the session here. Thank you and all the very best.